Alright, in this video I'm going to show you guys how to solve for angles using our trig functions. So a little bit of review here. Sine, good old sine, definition was opposite over hypotenuse, or OPP over HYP. Cosine was adjacent over hypotenuse, or ADJ over HYP. And our good buddy tangent was opposite over adjacent, or OPP over ADJ. So we're still going to use sine, cosine, and tangent to help us solve for missing angles. But we're going to do a little bit different function on our calculator to help us figure out missing angles. Previously, we'd use sine, cosine, and tangent to solve for a missing side, like if we were missing the opposite side, or the adjacent side, or the hypotenuse. We use sine, cosine, and tangent to help us solve for those. But today, we talk about how we can use sine, cosine, and tangent to help us solve for angles in the triangle that we cannot figure out. So again, you can remember SOHCAHTOA is just that sine is equal to the opposite over the hypotenuse side, that cosine is equal to the adjacent over the hypotenuse side, and that tangent is equal to the opposite over adjacent sides. So again, if you want to write SOHCAHTOA at the top of your papers, you can always just have a quick reference of what the definitions of sine, cosine, and tangent were. All right. So we are going to use sine, cosine, and tangent to calculate actual angles, but in order to do that, we need to know two of the sides of our right triangle. So out of opposite, adjacent, and hypotenuse, we need to know 2 out of 3 of those sides, at least 2. If we know all 3 sides, then we have more options at our disposal to help us figure out the missing angles. So in this problem here, imagine I want to try to figure out how big angle A is. All right. So if I wanted to figure out how big actually angle A was, well, some of you might go, well, it would be really helpful if we knew what this other angle up here was, because then we could just take 180 minus this 90 minus this angle, and that would give us the third angle. But in all these problems that we're going to look at, the only angle that we'll actually know in the triangle will only be the 90-degree angle. So we're going to be missing 2 angles, and we're going to figure out how could we figure out one of those missing angles out of those 2 that we don't know. So in this triangle, notice I've got 2 sides here. So this is the bare minimum of knowing 2 sides. And the opposite side is one of these 3's, opposite of the angle A. And this 3 represents the adjacent side. So opposite and adjacent, that is a tangent setup, right? So we'd set up the tangent of our angle, but we don't know what the angle is. So we would just put in A, for instance. But that's equal to the opposite side, which is 3, over the adjacent side, which is 3. Now you might be wondering, why do you also have sine and cosine here? Do you just have those to have all 3 options out? Because we don't know what the hypotenuse is. But something we learned earlier this chapter was the Pythagorean Theorem. And with the Pythagorean Theorem, if we knew 2 sides of a right triangle, well, then we could solve for the third side of the right triangle. So if we use Pythagorean Theorem, we could set up, and then again, this is our c side, is the hypotenuse. We could set up c squared equals a squared plus b squared, and then we could have c squared equals 3 squared plus 3 squared. And so c squared is equal to 9 plus 9, and we can add the 9 and 9 together to get 18, and then we'd square root both sides. And the square root of 18 comes out to be approximately 4.24. So let's say you actually figured out what the third side of that right triangle was. Well, now you could use sine, because the opposite side is 3, and the hypotenuse is the 4.24. And the cosine would be 3 for the adjacent side, and the hypotenuse 4.24. So what I'm trying to illustrate here is that with this particular problem, and another problem later on, is that if you have more than one option for a trig ratio to use out of sine, cosine, and tangent, you could use any of them if you really wanted to. So now I'm going to show you, once you have your ratio set up, well then how do we get these angle A's all by themselves? So we're going to use what's called inverse trig ratios. And on your calculators, you're going to have to find, again, your sine, cosine, tangent buttons. But if you look right above the sine, cosine, and tangent. So let me bring up a calculator here. And so notice in this calculator, here's the sine, cosine, tangent buttons. And right above them, you'll see a little sign, and it looks like an exponent here. Sine to the -1, cosine to the -1, tangent to the -1. And to get to those, you have to press the second button. So if I wanted to get to the inverse sine, I'd have to press second sine, and then there's that sine -1. And if I needed to get to inverse tangent, then second tangent to get to that tan -1. And the same thing for inverse cosine. So we're going to use these functions to help us solve for our missing angles. So let's actually put it into practice now. Let's look at the first example. We want to solve for angle x. So let's see what type of problem that we have set up for us. So the 3 is the opposite side, and the 4 is the adjacent side. And so opposite and adjacent, this is already a tangent problem. So we would set up the tangent of our angle, but we don't know what the angle is. So there's our x is equal to the opposite side, 3, over the adjacent side, 4. Now, usually when we did trig, the x was either in the numerator or the denominator of our fraction, but now it's the angle. And so now the question is, if we need to get this x all by itself, well, how do we get rid of just the tangent off the x? And so just like we get rid of addition by subtracting, and we get rid of multiplication by dividing, to get rid of tangent, we're going to do the opposite of tangent. So what is the opposite of tangent? Is inverse tangent. So here's what it's going to look like. We're going to take the inverse tangent of both sides. And so first let me do this. Let me just have my regular problem set up here. And then I'm going to put some more space over here for this opposite over adjacent. What we're really going to do is we're going to take the inverse tangent of both the left and the right sides of our equation. Now, this isn't multiplying by inverse tangent. This is a function itself. It's kind of like square rooting both sides, if you will. So the inverse tangent of tangent just cancels each other. Again, it's like square rooting a square or squaring a square root. They just knock each other out. And then we're going to be left with just x. And then what we're going to have to type into our calculator, let me fix this equal sign real quick. What we're going to type into our calculator is this, the inverse tangent of 3 divided by 4. And we're not going to use our ABC fraction for the 3/4 here. We're just going to use the divided by button. All right, so let's go back to my calculator. And so I want to do inverse tangent, so second tangent, and then 3 divided by 4, and then in my parenthesis here. And I get 36 point blah, 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 blah. Now, this is an angle measure. This isn't how long any sides are, but this is how big angle x is. Now, typically, we will round our angles to the nearest whole number. Now, if you want to throw in a couple decimal places like we did with our sides, you certainly can. But typically, angles will do to the nearest whole number. So 36.8, that 0.8 is going to bump our 6 up to a 37-degree angle. So in the end, I would say that x is approximately 37 degrees. And there's angle x. Now, could we have used sine or cosine in this problem? Well, to use sine or cosine, we would need to know what the hypotenuse is. And keep in mind, just like I showed you earlier, we could use the Pythagorean Theorem to figure out how long the hypotenuse is, and then you could have used sine or cosine in this problem. Now, the great thing about trigonometry is that it doesn't matter. If you have options of doing sine, cosine, or tangent, no matter which one you pick, as long as it's something that can be set up, sine, cosine, and tangent will give you the same exact answer, as long as you're using the correct values with them. All right, let's look at number 2. Solve for angle M. So where's angle M? Here's angle M down here. So let's label our sides accordingly like we have in the past. So we've got the 8 and the 17 on the label here. Well, the 17 is opposite the 90-degree angle. It's the hypotenuse. And the 8 is right next to the m, so it is the adjacent side. So the opposite side all the way over here, we're not using it, so we're not even going to consider it. So this is an adjacent and a hypotenuse problem. So was that a sine, cosine, or tangent setup? And it was a cosine setup. So we would set up the cosine of our angle, but we don't know the angle, so we're going to put m is equal to the adjacent side first, 8, over the hypotenuse, 17. And so again, we want to try to get m all by itself, but we got to get rid of this cosine. And so what is the opposite of cosining? It is the inverse cosine. So we're going to take the inverse cosine of the left side and the inverse cosine, and this is where it gets kind of tricky. I got to kind of squeeze it in here, the inverse cosine of the right side. So what I'm doing is algebraically correct. What I'm doing to one side of the equation, I'm doing to the other side. And again, we're not multiplying inverse cosine by cosine. This is like square rooting a square. So the inverse cosine and cosine knock each other out. So that leaves us with just m now over here on the left side. And then we need to type into our calculator the inverse cosine of 8 divided by 17. And so m will be approximately, and then let's go back to our calculator. Let's clear this out. So inverse cosine, remember you got to press second first and then cosine. And then 8 divided by 17. We'll end our parenthesis here. So 61.9, that 0.9 is going to bump up our 1 to a 2, so 62 degrees approximately. And there's example 2. And the last example, we're going to figure out what the two unknown angles are here. And the two unknown angles are angle A and angle C. We know how big angle B is. It's 90 degrees. And you might think, oh man, we're going to have to set up two trig equations here. But, well, I will say that you can set up two trig equations, one to figure out angle A and one to figure out angle C. But once we figure out how big A or C is, then we'll know 2 out of the 3 angles in a triangle, and we'll know that all 3 angles add up to be 180, so we don't have to set up a second trig problem. All right, so let's start alphabetically here. Let's figure out how big angle A is, and let's label our sides. So the hypotenuse, seems like you guys like to label the hypotenuse first. So opposite the 90, the 29, there's the hypotenuse. The other side that is touching the angle A that's not the hypotenuse has to be the adjacent. And all the way across from angle A, the 20 is the opposite. Now, notice here that we know the opposite, the adjacent, and the hypotenuse sides. We could set up a sine problem, we could set up a cosine problem, we could set up a tangent problem. So if you are in this scenario, it doesn't matter which one you pick, just as long as you pick one and then correctly set it up. Now, in the previous 2 problems, we've done a cosine problem and a tangent problem. So just to make things equitable around here, let's do this last problem as a sine problem. All right? So let's set up the sine of our angle, angle A, is equal to the opposite side first, 20, over the hypotenuse side, 29. And so again, we need to get A all by itself. So how do we get rid of sine? What is the opposite of sining? It will be the inverse sine of both sides. So the inverse sine of the left side and the inverse sine of the right side. Over here, once again, the inverse sine and sine knock each other out. They undo each other, leaving us with just angle A. And then in our calculators, we're going to have to type in the inverse sine of 20 divided by 29. And let's figure out what that is approximately. So back to our calculator. So if I want to do inverse sine, remember I got to press second and then sine. And then 20 divided by 29 into my parenthesis. And 43.6, and that 0.6 is going to round my 3 up to 44 degrees. So there's angle A. But we also needed to figure out what angle C was as well. But angle C, again, if we know 2 angles in our triangle, then we can just take 180 degrees, and we can get rid of the 90-degree angle, down here at angle B, and we can subtract away the 44-degree angle that we just figured out that angle A was down here. And so 180 minus 90 minus 44 is going to leave us with 46 degrees. Now, if you really wanted to, you could have set up a trig ratio to solve for angle C. Except the only little thing that you would have to correct is that using angle C as your beginning point, well, then the 21's no longer the adjacent side, it's the opposite side of angle C. And the 20 is no longer the opposite side, like angle A, but the 20 is the adjacent side to angle C. But the 29 hypotenuse is still the hypotenuse. So that's kind of a little issue if you wanted to try to set up a second trig ratio, is you would have to rename your opposite and adjacent sides. So I would recommend just subtracting your two angles that you know from 180 and get the third side from there. And that is all for this video. Good luck with your homework.